कुहतु सर.
Hello everyone, myself Gautam Gormaji. I am a lecturer in Metallurgical Engineering Department, UGA Rourkela. So today we have chosen the topic. We have chosen the subject Ferrous Metallurgy 1. So course code is 31 and it is a subject of third semester Metallurgical Engineering Department. For today's lecture, I have chosen the topic evaluation of iron ore. So in today's lecture, we will learn how should you do evaluation of iron ore. So let's start with the questions. What is the requirement of evaluation of iron ore? Why should we evaluate an iron ore? The answer is we should evaluate an iron ore so that we will know whether the iron ore is useful for us or not, whether we can extract iron from it or not, whether extraction of iron ore is economical from that ore or not. So in order to evaluate an iron ore, there are certain parameters based upon which we evaluate an iron ore. So what are those parameters? The first parameter is richness. Richness means the percentage of metallic iron. That means how much amount or how much percentage of iron is present in our ore, in that iron ore. So we know that in an iron ore there is not only the iron is present, but also there are various gangue materials are also present. So richness decides or richness tells us about what is the percentage of iron that is present in that ore. For example, let's take two iron ore, like one iron ore A and iron ore B. In iron ore A, there is 70% Fe2O3 that is hematite, and in another ore there is 80% Fe2O3. So that means in case of the ore, that is iron ore B, where the Fe2O3 content is 80%, definitely it contains more amount of iron. So if that ore contains more amount of iron, that means we require less amount of ore to produce 1 ton of iron, or to extract 1 ton of iron from that ore, we require less amount of iron ore if the richness of ore is higher. So higher the richness of ore, lesser will be the amount of ore requirement, but I have already told. And also for richer ore or ore which contains more amount of iron, we require less amount of flux, as it contains less amount of gangue material. And also as the gangue material is less, we will also require less amount of coke. The coke rate will be lower. Then the next parameter is location. So for location there are two different kind of location. One is geographical location and another is geological location. So geological location concerned about where the ore is present on the earth crust. Is it above the earth crust, or is it above the earth crust, or it is below the earth crust? That means if the ore is present above the earth crust in terms of mountains, so it is easier for us to mine it out. That means we have to spend less amount of money to mine it out. Whereas if the ore is present below the earth crust, we have to spend more amount of money in order to mine it. That means that ore will be more costlier as compared to the so as I have already told, geological locations means whether the ore is present above the ground or below the ground. So if it is like harder to mine out the ore, so it will be more costlier. So if it is more costlier, that means we will prefer that ore less, because the hot metal cost will be higher, the production cost will be higher, so we will not consider that ore. So when it comes to geographical location means the mode of transport required to bring that ore to the industry. If the ore is present in very remote area, that means there is no communication, is that rail communication or by water communication. If it is not there, then it will be costlier for us to bring that ore from the mines to the industry. Whereas if the ore is present in an area where the transportation is already there, so it will be cheaper for us to mine that ore, or the cost of that ore will be less. Then the next parameter is composition of gangue. Like we already know, in an ore there is, like if we consider iron ore, there is Fe2O3 hematite is there and various other gangue materials are there. What are the various gangue materials in iron ore? Mostly alumina, silica, calcium carbonate, and titanium oxide, and various other kinds of oxides are present as gangue material in that ore. So composition of gangue is, the composition of aspect of iron ore may decrease the value of H or increase the value of H. That means if, like for example, if we have two ores, iron ore A and iron ore B, if iron ore A contains, like iron ore A is more richer, like it contains more Fe content as compared to iron ore B. But in iron ore A, the gangue composition is very complicated. That means if the gangue contains more amount of alumina or such gangue materials which is not easily removable inside the blast furnace or other alternative route, then that ore will prefer that ore less as compared to the other ore. Still it has higher content, but we will not prefer that ore because it has certain content of gangue which is very difficult for us to remove during the iron making process. So for that we will not consider that ore as compared to the other ore which has such gangue material which is easily removable during iron making process. So it is already said that the effect of associated gangue is related to its nature, whether it entirely stays in slag or partially or entirely in metal. So if it stays completely in slag, the gangue material, if it stays completely in slag, so that is good for us. That means it is easily removable. But if it is present in the metal, then that is a difficult task for us. We cannot remove that gangue material easily, or we cannot remove the gangue material in forms of slag easily. So it will be difficult for us to tackle. So if the ore contains gangue that stays in metal phase, it increases the valuation of ore. That means we will consider that ore less as compared to the ore which contains gangue which present in the stage in slag phase. So the next parameter is treatment and preparation needed. That means what are the various mineral dressing or mineral processing techniques needed for that ore from mines to the furnace. Right. If the treatment is like if we have to treat the ore more and more, at every step of treatment or every step of mineral dressing, it will increase the cost. Right. The treatment and preparation required for an ore to be made suitable for blast furnace uses decide the cost of that ore. If the ore is dense, then we have to crush it. If the ore is to make it porous, if the ore is in finer form, then we have to agglomerate, we have to do sintering, we have to do pelletizing. All these are to the cost of the ore. Like if an ore is directly, if you can directly use it in the blast furnace, it will be cheaper as compared to ore which we have to agglomerate. If the ore is in powder form, we have to first agglomerate so that we can use it in blast furnace. So in that case, it will be more costlier for us. So the takeaway is, if the treatment is more, if we have to do various stages of treatment to make the ore suitable for blast furnace use, then we will prefer that ore less because the ore will be more costlier in that case. Then the final parameter which we use to decide whether to use that ore or not is end use. End use means where the ore is being in use. Like we know, for iron making, there are two broadly categorized. There are two processes. One is the blast furnace process, and another is the alternative route process. So, if the ore is like the end use means where the ore is being used finally, whether it is used in blast furnace or it is used in alternative iron making process. So, for some like some ore is more suitable for blast furnace, some ore is more suitable for alternative iron making process like sponge iron process. So maybe some ore is costlier for blast furnace, but that ore will be cheaper for sponge iron process. So the final where we are using that ore, that also like that also a deciding factor whether we should use that ore or not. Then finally the values, like the main or the takeaway or the gist of this lecture is the value of an iron ore is decided not only by the Fe content alone. That means we do not consider an ore which has higher Fe content, like in general we value that thing which contains like what we want is Fe. So in general we should consider an ore which has more Fe content as compared to the ore which has less Fe content. But it is not always true. Like we have also seen various parameters which are also deciding factor whether we should use that ore or not. Only Fe content is not the factor, like only the richness is not the factor whether we should choose an ore for iron making or not. So there are various other minerals, like only Fe content is not only the parameter, also by various other minerals associated with it and various other factors like the geographical, geological, like the location factor, the treatment factor. All those things also have to be taken in account in order to decide whether we should use that ore or whether we should choose that ore over another ore, or whether that ore is economical, whether using that ore will be economical for us or not. Okay. So this is all for this lecture.